Hello, and welcome to our short presentation of our work on using activation functions for improving measure-level audio synchronization. My name is Özer, and this is a joint work with Ištvánek, Arifi-Müller, and Müller. Arifi-Müller, Müller, and I are with the International Audio Laboratories Erlangen, Germany. Ištvánek is with Brno Institute of Technology, Brno, Czech Republic. In this work, we are dealing with audio-to-audio synchronization, which defines the alignment of multiple recordings of the same piece. Traditional synchronization approaches are often based on dynamic time warping with chroma features, but for the music recordings involving soft onsets and abrupt tempo changes, chroma features can be unreliable. To provide a better temporal resolution of the synchronization, we introduce a combined approach that integrates activation functions into the synchronization pipeline. We compare several synchronization approaches where we transfer measure annotations from a reference recording to a target recording. For the combined synchronization approach, we regard activation function as a function that yields a value between 0 and 1. Each entry indicates the likelihood of a certain musical event. To this end, we use conventional onset-based activation functions and recent deep learning-based methods. First, we use onset-based activation functions. Here you see an excerpt from the score of the string quartet number 12 in F major by Antonin Dvorak and its corresponding chroma feature representation. As onset-based activation functions, we use the decaying locally adaptive chroma onset features, as known as DL&CO, spectral flex, which is widely used for onset detection, and superflex, which is a modified version of the spectral flex and is especially suitable for music recordings with vibrato and soft onsets. Additionally, we use DL-based activation functions as the CNN onset detector, which we call as DLO, RNN beat detector, which we denote as DLB, and finally RNN downbeat detector, denoted as DLT. Here we adapt the combined synchronization approach by Evert, Müller, and Grosche. We first introduce three cost matrices. The first one is based on chroma. The second one is activation function based. Note that the visible horizontal and vertical grid lines of high cost correspond to high values in the first and second activation functions. Only when a horizontal grid line intersects with a vertical grid line, the cost matrix has a small cost value at this intersection point. This method enhances the temporal accuracy of the synchronization. Finally, the sum of these two matrices accounts for harmonic and melodic information with the first cost matrix and additional activation cues with the second cost matrix. Our dataset comprises three different versions of the string quartet number 12 in F major by Antonin Dvorak, which has 4 movements. Here we compare 8 different synchronization approaches, and the experimental results indicate that the combination of DLO, DLB, and DLD, denoted as DLOBD, outperforms the conventional methods and the DL-based methods. I would be delighted to talk about further details in the poster session, online or in Bengaluru. Thanks for watching.